Hi, I want to continue to my previous video about why the Linux top command shows CPU usage 0.0%, and for the big IP TMM process. So here is my big IP virtual guest. So I upgraded it to a newer big IP version, and so the newer big IP version would have a newer Linux kernel running, and so here is a two big IP version in two software slot. My previous version runs on the 14.1.0, which has the problem of 0.0 CPU usage percentage. So I upgraded it to big IP 15.1.0, which has a newer kernel version. And let's see if this version has the problem or not. So let's run. So I already have my node test running already. So let's just take a look at the CPU usage of TMM process. Dash capital H is to show the thread also. So actually my node testing has been running for a while, and as you can see, it looks normal, right? It's also reflected in the summary section. So no 0.0% problem. So and that's what I did, and so I kind of maybe this is a Linux kernel problem. And so by the way, TMM is a process running in the user space, and it's running in a pool mode, and so it's always pulling the it's a user space always pulling the data from the driver. So yeah, so let's then what's the actual kernel problem then? And so I basically the big IP used the Linux kernel originated from Red Hat or CentOS. So I basically mapped to the different big IP version to the CentOS Linux kernel, and so I did a commit history check, and also I pull the upstream Linux kernel and to find the commit history, and eventually I isolated the two Linux kernel commit, and one is this. Another commit is this commit. It's a regression, a fixed node HD for monotonicity regression, and so because the big IP also has this kernel config enabled, we can double check the kernel config here, and it has this no HD4 kernel config enabled. So, and I think the actual kernel bug should be this commit, and because this commit exists in the newer BIP 15.1.1 kernel, but not in the 14.1.0 kernel. So this is the kernel bug, and so here there is also a mailing list to discuss this kernel bug here. Yeah, I already have on the page. So this is the actual mailing list, the main email thread talking about this bug, and so the actual fix is the comment actually explains the fix. If either the S time or both the S time and the U time are 0, and assume all runtime is user space, which in this case, for the big IP, since the TMM is the user space traffic processing process, so it's pretty much all the runtime is spent in the user space. So match this description, and also the kernel config was no HZ full also labeled. So I can pretty sure this is the bug. And so by the way, S time is for a process that the time spent in the kernel, and the U time is the time spent in the user space, and in nanosecond. And so here we can go to the actual, yeah, so in the upstream Linux kernel we can show the actual commit ID, and it shows the actual commit fixes and a comment. And yeah, so again in the commit it has that's the code comment and the changes. Yeah, so the actual file for process CPU time tracking is actually in this file, CPU time, and I think CPU time adjusted. So that's the function. So by the way, like for the CPU time for process, and it's defined in this CPU time dot structure. Oh, not this structure. I think yeah, it's this structure, task CPU time. Yeah. So this is a data structure to describe process CPU time, and so U time. Okay, here U time is the time spent in user mode, and in nanosecond. S time is the time spent in kernel mode, and the sum exact runtime is total time spent on the CPU, your nanoseconds. And yeah, so that's this three to track a process CPU time. And scale. S time. So here is the function for CPU time adjustment, and this is a comment like just a tick-based CPU time random precision against the scheduler runtime accounting. So the S time actually is adjusted according to the time spent in the kernel. S time, system time, is actually adjusted, scaled based on the scheduler runtime for the process. And so in this function, it's basically make sure S time and U time is incrementally it's increased and not going backward, and also make sure the total runtime is equal to system time and the user mode time. So that's basically what this function does. And the CPU time adjusted, and it's called by a task CPU time adjusted, or for a thread group CPU time adjusted. Yeah, so that's a little background about how a process CPU time is tracked, and the kernel bug. Yeah, and hope this clarify a little bit and helps. So yeah, thank you.